Thanks for having me, Dataiku and Julke. I'm going to talk about modeling and deploying house prices with Dataiku. It's not going to be a very long presentation because, well, Dataiku has made it too easy. It's pushing a few buttons, so don't expect too much code. I'm going to talk a little bit about the model, and that's house price or home value prediction using Jaap.nl. And I'm going to give a short demo on the model deployment side, how to deploy a predictive model. So I guess all of you know Jaap.nl. If you are in the Netherlands and you want to buy a house, you can go to Jaap.nl and then look for a certain house and then see the prices, etc. You can scrape Jaap.nl, and then you can obtain some nice and interesting data. And so how does that data look like? Well, you would get around 130,000 houses. Per house, you would get the type of house, so a tussenwoning or a villa or an apartment. The number of rooms it has, the location, of course, the surface area, how much square meters does the house have, and of course, yeah, it's in my pocket. Push. 2 or 3 seconds. Okay. Yeah. Okay. And of course, very important, the price of the house. How much does the house cost? And now the model that you can create is predict the price given these features of the house, right?
These asking prices or transaction prices?
These are asking prices. On Jaap.nl, I don't have the real transaction price, of course. That's between the buyer and the... but this is a good indication, I guess. So first, in Dataiku, of course, you can create some plots, and let's see where the expensive houses are. You would see immediately Amsterdam-Zuid, Naarden, het Gooi. First, to get an impression on the data, you can create scatter plots like this, the surface against the price. So the more surface area you have, of course, the more the house will cost. Lots of variation, of course. You can make a scatter plot, or you can make a bar chart per type of house, and you would see the villas, most expensive house on average, more than 600,000 euros. And an apartment, this is on the top, on the bottom, recreatiewoning or apartment, a little bit less than 200,000 euros. Now, so I'm not going to tell a lot about the modeling, but I'm going to just use Dataiku to create a price model. So I'll just select price as the target variable, and all of these other variables are going to be inputs, features that are going to use to predict the price. Oppervlakte, the number of rooms, etc. Then I select a number of algorithms, random forest, gradient boost, a normal linear regression, an XGBoost, etc. And the nice thing is you can turn on hyperparameter search in Dataiku with these settings here. And I'll go into the software later, yes?
What kind of tuning does it do?
For now, it's a grid search, most simple tuning. And you would see it here. You turn the computer on, and on my laptop, all these models are trained and fine-tuned. And the winner in this case is an XGBoost model. You have an R² of 0.657 and an ordinary least square 0.57. And you would see all the iterations, all the different types of models it has fitted. Okay, it took about an hour on my little laptop to run. How does the model look like? Well, let's take a linear regression. That's the most simple model. It's explainable, but it's not really the most predictable model. So you would start by 24,000 euros, and then if your house is in Amsterdam, postcode 10, first 2 digits of the postcode, then you would add 240,000 euros. If your house would be in 9.6, that's the earthquake area in the Netherlands, then you would subtract 100,000 euros. So you're negative. But you can make up for the house type. Suppose you have a villa, you would add up 173,000 euros. And then this is an important parameter, the price per square meter. So if you have let's say 100 square meters, then it's 2,000 euro per square meter. So it's 200,000 euros on top of that. And then a small extra, each additional room will get you 4,500 euros. So if you have 5-room home, it's 5 times this number. This is a reasonable model, an R-square of 0.57. An XGBoost model is better, but it's harder to explain an XGBoost model. But you get a feeling of the price model. And this actual data. Okay, so now what? I have a model. Suppose you have a dream house that you want to buy. What's the price of this? What's the predicted price of this house? What can you do? Well, you can mail me with the features. I run this model on my laptop and I would say, okay, 500,000 euros. But, wait a second, please don't do that because, well, it's manual work and I might not get only one email, but I might start getting thousands of emails. So, of course, you need something more fancy than that to create house prices. So what can you do with Dataiku? Set up a server with Dataiku that can handle these requests. That's called model deployment. Dataiku supports the creation of a so-called REST API that can handle the predictions, the deployment of APIs, the management of these APIs can be handled with Dataiku. And to give you an impression of how that looks, on what the components are involved in the whole setup, I'm going to show you a few slides first. So first you have the Dataiku software. It sits on the server. You use a laptop with, let's say, a browser, and then as a data scientist, you would create models with Dataiku. Then you need an additional component, the Dataiku deployer. That deployer is installed on a server, could be on your laptop, but could be a separate server. The installation of the Dataiku deployer is just this simple command, if you have downloaded the software. And then you need API nodes, and that's a component that will do the actual handling of the API request. And that's an additional installation of Dataiku with a separate parameter, -t API, and a specific port. And you can install it on physical hardware or on virtual machines in the cloud. That doesn't matter. So the setup would look like this. You have Dataiku, create your model, you push that model to a deployer, and from that deployer, it has its own management interface. You can push it to the nodes that will handle the request. This is one way to do it. And the other way how to do it, and I will also demonstrate that, is use Kubernetes. So you don't need physical or virtual machines where you need to install Dataiku, but you need a Docker cluster, a cluster, a Kubernetes. It could be in the cloud, could also be physical somewhere, but preferably you could do it in the cloud on Google, for example. Yeah? So a short demo. First, Dataiku, how the model is created, and then the setup of a cluster and the API deployer. First, I'm going to create a cluster, and I've already done that. And if you're making use of the Google Cloud SDK, you can just issue this command, gcloud container cluster create my first cluster. It will take a minute or so, or even less, but I've already done that. And you can then list, Okay, it's up and running, my cluster, and also if you go to the Google Cloud Console, I'm in here, my Cloud Console, and say, my first cluster, it's up and running. Now, okay, I can't do much of it. That's the back end. Now I'm going to go to Dataiku. I'm going to go to my YAP project, and I'll show you, go to the flow and to the data set. Now, this is the small data set that I've showed you earlier. I've scraped it from YAP, all these houses. And I didn't do a lot of fancy data preparation stuff. Just for the sake of time, I'm going to show you the analysis. So what I've done here is create a multiple models. And these are here. So this is the same list again. And you could go to the different models. And let's say a random forest is interesting. Then you click on random forest. And you would see a variable importance. And by far the most important feature of a house is the surface area and also the location. Is it in Amsterdam or not? This is the Amsterdam effect. If your house is in Amsterdam, then all of a sudden it's worth much more than the rest of the Netherlands. You can create a scatter plot, the price versus the actual values versus the prediction, so you can get an idea of how good the model really is visually. But now let's deploy the whole thing. So I'm going to deploy it. Deploy as a new retrainable model. Click on create. Let's type in a name so that you see it's real. Let's say random forest meetup. Would be a silly name to use, but okay. Now you see here an additional model, random forest meetup. And what can you now do with it? Select it, and you start create an API by pushing this button here. The API service needs to have a name, so let's say home value, and it probably complains that I already have it, so let's say home value 2, endpoint random forest, append. It's going to create this interface now. I can now push it to the API deployer. So I'm still in my data science studio from Dataiku as a data scientist. I can push it to the API deployer. Click OK. It's going to build a package. And then I'm going to switch from interface. It's a different port now. This could be on a different machine, the API deployer. It's now on my laptop, so it's a little bit of the same machine. I'm going to refresh. And you would see here now home value 2, new. This is a model waiting to be deployed. And in this interface, you would first define an infrastructure. That could be physical machines, or it could be machines on DigitalOcean, or it could be Kubernetes, so on your Google Kubernetes engine. Let's take a simple machine first, DigitalOcean. Do you know DigitalOcean? DigitalOcean is a cloud provider where you can spin up a Linux machine just in a few seconds. You can do that also on Google, of course, but I like DigitalOcean. And I have an IP address here, so I need to specify an IP address, and I need to install the Dataiku deployer, the Dataiku API nodes on this machine. I've done that. So now it's up and running. And what I can do now is go to the home value model. I can say deploy. I can select an infrastructure, let's say DigitalOcean, and deploy. Start it. Okay, it's up and running. Now, this little code, it's a curl call to an API can now be run. So I'm going to copy this. And I open a terminal, and you see it here. This is on my little server on DigitalOcean. If I make a home prediction of a tussenwoning with 6 rooms and 134 square meters in Amsterdam, well, let's first do the lovely city of Horen. That's where I've been grown up. Would select this. Control Enter. And you see a prediction of the house. This house will cost you 227,000 euros, right? Now I change one little thing. In Amsterdam, exactly the same house. Run it again. So how much does it cost now? 690,000 euros. So that's quite a difference, right? For exactly the same house, except in Horen, it's now in Amsterdam. This model is up and running. If you take this address, it's available now. I pay €5 per month to have this machine up and running. So, and now it has this model also running. So if you can go to this address and make a curl call with your favorite house, then you will get the prediction of the house. Okay, now, but what if this model is so successful that I would get millions of requests per hour? Well, then my little machine on DigitalOcean, €5 per month, cannot handle those requests anymore. It will crash. So then it could be very handy to have a scalable backend. And Google Cloud Platform with the Kubernetes engine will give you this. So I have now this little Kubernetes cluster. It has 3 nodes, small nodes, because I don't want to pay a lot of money now for this little demonstration. This will cost you around €1 now. I've done this before, and afterwards I looked at the bill and said, okay, that's €1, so it's acceptable. But it's not a big cluster. It only has 3 nodes. And how would you now deploy your model? Well, you go back to the API deployer. You go to the infrastructure, and you need to define a link to the Google Kubernetes engine, and that can be set here. So you specify the name of the Google project that contains the Kubernetes engine, and your machine should be able to talk to Google. And if you have installed Google Cloud SDK, you are able to do that. So basically, this is it. This is the setup. So I'm going to go back to my deployment, and I'm going to deploy. And now instead of selecting DigitalOcean, I'm selecting Google Cloud Engine. And deployment ID, okay, deploy, start. It's going to take a little bit longer. It's going to package this model into a Docker container and then push that to the Google Cloud. And while it's doing that, I'm going to show you another nice thing. So in this flow, I have some models, an XGBoost, a random forest, and I can deploy that. But you can also deploy any R or Python function, the same as you did with models. And that's quite fancy. So what you can do is go to the API designer, and you would define a new API service. Let's say my Python. Click on OK. Create an endpoint. And now I'm going to deploy a Python function. And let's say my py123, something like that. Append. And here you can define just any Python function you want. Now, I promised somebody to show some code. This is the code. Python function, so it's not very fancy, but okay, it takes 3 parameters and it adds the first 2 times 3. Okay, let's say this is your Python function. I don't have much inspiration now, so I'm going to push this. Click on OK. and it's pushed to the deployer. So if I go back to the deployer, it's still working. Let's open another interface. You would see here my Python. It's new. It's ready for deployment. So I'm going to click on deploy. Let's select an infrastructure. Let's do this on DigitalOcean. Click deploy. Deploy it. Okay, it's up and running. This is the curl, and you need a shell window to run it. It's already here. And then 3 parameters. Let's say these 3 parameters here. So it's a curl call to this API, myPython, mypy123. This was the name, the silly name I gave. So, and if I run this, you can now call a Python function on my DigitalOcean server. Not really exciting, but this is the result. You get some timing statistics as well. Let's see how my random forest is. Yeah, it's working. I have my house model deployed on GKE, Google Kubernetes Engines. It's a green light. You can run this model. And if you go to your console on Google and you go to the services, well, first you see the cluster, but then there are services on this cluster. And yes, it's my house model. It has a load balancer, and this is the endpoint. And now I can start calling this. So I'm going to go back to here, open this model, get some sample code, and the only thing I need is this address. Paste it in, and I can replace this. Because each time you spin up a new cluster on Google, you would get a new IP address. And so the previous demo I did had an old address. And yeah, you can start calling it. So you get a prediction now. This is a different model than I had on the DigitalOcean, because there I was an XGBoost, and this is a random forest. But now I'm ready for the millions of requests that are coming in. Because what will it take to scale? Well, you go to the Kubernetes engine, and you could increase your number of cluster. Let's say you have more and more hits, more and more requests. You would scale it up, and that's it. And of course, if you want to stop incurring cost, you would terminate the cluster altogether. So this is always the last. And don't forget it. Google G Cloud Container Cluster delete. And it's now deleting, asking yes. And it's deleting the cluster. And then you would see this light going to red, because this, you see it already, this model is not up and running anymore. So this is a nice sort of management console to manage your different deployments of the different models. You see you could have more models, you could have Python functions. Within a model you could have different versions, and it can easily be managed from this deployer console. That's basically it. Deploying a model on Google or on DigitalOcean. Any questions? Yeah.
When you listed all the models, you gave information about the performance of the different models.
Yeah.
How did you estimate these performance? Is it based on training and testing? Or
Yeah.
more comment on that, or explain more in detail how this works?
I had my data set with 130,000 houses. If you train a model in Dataiku, it will ask you, do you want to split the data in a train and test? So it will train a model on a train set and take the test set to calculate the metrics like the R-squared, or if it's a classification model, you get different metrics. But that's how it works. Yeah.
Yeah, can you go to that slide where you had those question as well?
Which one? This one?
No, the model performance where you.
Oh, this one, yeah.
Yes. Could you do early stopping as well?
You mean in time by cutting off? Yes, you can. For sure, manually. Just you wait an hour and then you cancel the thing, but then you have all these intermediate things. I'm not sure if there's a hard timer to set. Is there?
Setting you can do. So where you select to have the random search,
Yeah.
you can also specify the amount of parallel processes, but also the time.
A timer, yes, I thought so. Yeah, I wasn't sure because I haven't used that feature, but you can, yeah. If you have enough time, just let it run. There's a question in the back, yeah.
How does it compare, like cost-wise and scalability-wise, with like other frameworks like SageMaker, for example, in AWS?
I haven't used those framework to be honest. So, but you mean the deployment of the models, or?
Yeah, like cost, or is it more scalable, or is it cheaper than SageMaker, or?
The nice thing about the Dataiku deployment is there's a backend fitting these models. In this case, it's scikit-learn. So all these models are now scikit-learn models. But for most scikit-learn models, Dataiku, if it deploys the model, it creates optimized Java code. It doesn't use the plain Python code. So you would get faster model calculation, model prediction within milliseconds. And you don't need to do that yourself. Okay. Any other questions? If not, then clear. Yeah.
I will stop the live stream. And
Okay. Thank you.